Alright, today we're going to look at trigographs, and we are asked to find certain things related to it as well as to sketch it out. So the question given is y equals to 4 sine 3x plus 2, and they're actually going to ask you to sketch, later on you'll see from here, between 0 and 180 degrees. I'll explain in a while what the significance of this is. So let's have a look at the first question. You're supposed to state the amplitude and the period of the graph of this function here. Okay, so the first thing they need to remember is, for any general form, we have y equals to a sine bx plus c. Now, this a here actually represents the amplitude. So this will determine the highest and the lowest value that you will have, the maximum and the minimum. And this b here is actually the number of cycles that you can have. So in other words, the period of the graph will be affected. And finally, c has the effect of a translation. It means that your graph can either move up or move down based on the c value. If c is positive, it moves up. If c is negative, it moves down. So based on this, if you look at the question, 4 is actually your a value. So in other words, that will be your amplitude. Alright, so the question asks for amplitude. So your amplitude is just 4, since a is 4. Now, for the period, you have to look at this one here, 3, which is actually your b, correct? So in a normal cycle, for your period, you will have 360, correct? But since you can fit in 3 graphs or 3 cycles, now this 3 here means that within 360 you can fit in 3 graphs, 3 sine graphs. So which means that 360 divided by 3, you'll be able to get it as 120. So this is the period. It means that I only need 120 degrees in order to have a complete sine cycle, meaning that you have the mountain and the valley. You only need 120 degrees for one cycle. So this is the period. Now, the second question that you want you to do is to sketch the graph. In a normal setting, when you see that this here is 3x, sine 3x, like what was mentioned earlier, you would have to fit in 3 sine graphs for a graph that reaches up to 360. So in other words, I'm going to show you this. So for a normal function like this, 4 sine 3x, if x is between 0 and 360, you would be able to fit in 3 graphs, right? So you have mountain, valley, so this is the first, mountain, valley, this is the second, mountain, valley, this is the third. So you can fit in 3 graphs up to 360. However, for this question, they gave you a discount in the sense that you don't need to draw 3 full cycles. They only want you to draw up to 180 degrees. So if you look at this one here, right, they want between 0 and 180 degrees. So it means that you have 1 up to 120, and you just have another mountain, that's all, up to 180. So basically, you're only going to have 1.5 graphs, because instead of 360, you have 180, so you're only going to draw up to 1.5 graphs, alright? So this is how it's going to look like. Okay, so to make it a little bit quicker, I've already done up the axis. So to have the graph of y equals to, okay, I'm going to draw y equals to 4 sine 3x first. Alright, I'm not going to bother about the plus 2. I'm just going to draw this first, and I'm going to use a dotted line because this is not the final graph. So 4 sine 3x. Now remember, the amplitude now is 4, which means that my maximum and minimum will be 4 and negative 4 respectively. And I was supposed to fit in 3 cycles, but now I only need to draw up to 180, so I'm only going to have 1.5 cycles. And at 120, I will already have the full cycle of mountain and valley. So let's have a go at it. So the first point will be at 0. The second point will be here. So if this is 120, half of it is 60. And half of 60 here is actually 30. So at 30 degrees, this would have been the maximum. Then at 60, we we are back to 0 again. At 90, we are at -4. At 120, we are back at 0 again. So I'm going to draw the dotted line first. And this will be the first cycle. Now remember, we have 1.5 cycles, so which means that we will have at 0, then we are going to the maximum here, and then down to 180 again. So this is actually my 1.5 cycles. Okay, so this is actually going to be the graph of y equals to 4 sine 3x. So what happens when we have a +2? What happens then? So what we're going to do is that we are going to move everything up by 2. Alright? Now if originally I was at 0, I'm going to go to 2. It moves up by 2 units. My maximum is also going up by 2. Now this point was originally at 0, so it's going to go up to 2. And this value was originally -4, which means that it will go up to -2. And the same thing happens for the second cycle, the second half cycle. And so now I'm going to use a solid line to draw. So we have, this is my mountain, this is the valley. So this is one cycle, and I have another mountain, and that's it. I don't have a valley. So if you can imagine, right, I'm going to use a dotted line. So this is the imaginary axis. Okay, so this was the x-axis, right? So it was nicely balanced, mountain, valley, and mountain. So now that everything has shifted up by 2 units, so you realize that at 2, this will be the imaginary x-axis. So this is your mountain, valley, and another mountain. So this will be the second part where you have the graph sketched out. And from here, it will help you with the third part, stating the maximum and minimum value. So isn't it quite obvious that the maximum now is at 6, right? So we can write down there. So for part 3, maximum is actually 6, and the minimum, okay, let's go back to the graph again. So the minimum now, look at this. This was originally a -4, but you moved up by 2. So the minimum now is at -2. So there you have it, maximum and minimum. Let's go to the final part where they actually want a modulus. So what we have done so far, right, is actually we have this graph here, okay? Y equals to 4 sine 3x plus 2. So this is the one which is a solid line. Alright? So this was our solid one, which is the one with the +2. Now, what does modulus actually mean? Modulus just means that your x-axis, right, is able to cut your graph into the positive and the negative. Okay, I repeat. Now, if you can see, this is my ruler, right? So I'm just going to use it like a knife, and you'll see that this part here will be positive y values. This part here will be negative y values. Alright, so for a modulus graph, it just means that whatever was negative will now be positive. So which means that this was my lowest point, isn't it? At 90 degrees, it's actually -2. Since this is actually in the negative portion, when I do a flip, flipping it to the positive, it will actually go to 2. So I'm going to go in red. So this is going to be my modulus graph. Sorry, right? So this is actually the intercept here. Correct? And so this negative part will be flipped up. Okay, this negative part will be flipped up, and I'll just continue with the reds here. And there you have it. The one in red will be y equals to modulus 4 sine 3x plus 2. So this will be the modulus graph. The negative part is flipped up.